By this point, we've covered everything you need to know about multiplication, and we'll be moving into division, but there's a unit in between that I call finding factors. So we're going to take a look at some numbers and find patterns in them, and use that to develop our own rules for how we know if a given number can be evenly divided by another number. So we're going to take a look at 2, 3, 4, 5, 6, 9, and 10. And we're going to look for patterns of dividing those up and making sure we have even amounts with no leftovers. And then we're going to write rules for that. So you should have 2 papers in front of you. One is for taking notes on these divisibility rules, and another is a practice sheet. So you can put all of these into practice once you're done watching this video. Okay, so we're going to jump into divisible by 2. And we're going to be taking a deep look at each one of these and then develop a rule based on them. So let's take a look at the number 9. In this 10 frame, we have 9 owls, and we want to see, is it divisible by 2? So that means we want to break it up into groups of 2. So there's 2, another 2, another 2, another 2, and there's 1 left over. So we're not looking for an answer here. We're looking to see, is it evenly divisible, or are there leftover pieces? Okay, just a yes or no question, not a numerical answer. Okay, so this one is no. That is not evenly divisible by 2 because you can't break it up into even groups. There's an extra one left over. Let's take a look at 4. We have a group of 2 and a group of 2, and there's no leftover pieces. So yes, it is evenly divisible by 2. And then here we have 6. You can break it up into groups of 2s with no leftover pieces. Okay, so that's 3 examples. And our rule here is if the number is even, then it is evenly divisible by 2. Okay, so you can put that on your notes page, and we'll go a little bit faster through the other ones. I just wanted to start off with a kind of slow look at breaking things into groups so that you know what it means to be divisible by something. Okay, let's look at 3s. And we'll start off with the number 9. So let's see if we can break this into groups of 3s with nothing left over. So we have 1, 2, 3. 1, 2, 3. 1, 2, 3. It works out perfectly in groups of 3s with nothing left over. So we'd say yes, 9 works. Let's try 11. Okay, 1, 2, 3. 1, 2, 3. 1, 2, 3. And then 1, 2. It doesn't make a complete group. So 11 does not work. And then here we have 18. Now we already left off here, so I'll count that as our third one in that group, continuing from what we did with 11. So let's just continue here. 1, 2, 3, 1, 2, 3. So yes, 18 works. If you want to try that yourself, feel free to pause the video at any point and you can count them out. Okay, we're going to take a look at more numbers this time and just use what we know about multiplication to say yes or no. So is 15 evenly divisible by 3? Well, if you've done the whole multiplication unit up to this point, you'll know 15 divided by 3 equals 5. That works out perfectly, so yes. 21 divided by 3 is 7, so that works out. 28 divided by 3 does not work. There's some leftover pieces. 36 divided by 3 equals 12. That works out perfectly. What about a big number? We're always going to end this with a big number, and this is where we think about our pattern of what's happening with our numbers, and then we can apply it to a larger number without having to do a lot of math to see if it works perfectly. So the 3's trick is pretty cool. It doesn't have to do just with the number itself. It has to do with a little secret where you add the digits together, and you'll see a pattern happen with the numbers that are divisible by 3. So we know obviously 3 is divisible by 3. We know 6 is divisible by 3. We know 9 is divisible by 3. But what happens when you get into bigger numbers? Okay, 11 did not work. Let's look at what happens when you add those. 1 plus 1 is 2. Okay, that's on a list of things that don't work. Let's just look at the ones that do work now. So 1 plus 8 is 9, and we know that one does work. 15 works. 1 plus 5 is 6. 21 works. 2 plus 1 is 3. 36 works. 3 plus 6 is 9. Okay, pause the video and think about that. And then if you're ready to come back, let's think about what we know. We know that 3, 6, and 9 are divisible by 3. And then so far, everything else that is divisible by 3, the digits have added up to be either 3, 6, or 9. So that is the divisibility rule by 3. If the number either is 3, 6, or 9, or if the digits add to be 3, 6, or 9, then you know that the number will be divisible by 3. So that's a really cool trick that you may not think of, but once you know that trick, it makes it a lot easier to figure out. So now let's use that to figure out 144. So 1 plus 4 is 5. 5 plus 4 more is 9. So it should be divisible by 3. And then if you go to the work of dividing it out by 3, you do get 48. Exactly, there's no leftovers. So here is our divisibility rule. You can put this on your notes. If the digits add to 3, 6, or 9, then it is evenly divisible by 3. Now, once you get into really big numbers, you may add up all the digits and get something like 18. And that 18 is not a 3, 6, or 9, but if you add the digits in 18, 1 and 8, you get 9. So just keep adding the digits until you get down to 3, 6, or 9. And if it works, you're good. If it doesn't work, then you know it's not evenly divisible by 3 because there will be some leftovers. Okay, let's look at 4. The 4's trick is not one of the easiest tricks, actually, but there is a way to look at it, especially if the numbers are reasonably small. Okay, so let's start off with 8 and see if we can break that into even groups of 4. So we have a group of 4, and then there's 1, 2, 3, 4 more left. So yes, 8 works. Okay, how about 11? We have 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 3. It does not go into 4 evenly, so 11 is not divisible by 4. And then 18, you can pause the video and try that yourself if you want. 18 is not evenly divisible by 4. Let's take a look at numbers now without the pictures and just use what we know about our multiplication facts and see if we can find the pattern. So I want you to think about this as we're going. See if you can think about what the pattern will be before I tell you. Okay, 16. Can you divide 16 by 4? Yes, it equals 4. So that's a good one. How about 22? 22 you cannot divide evenly by 4. There will be some leftovers. 28. Yes, you can divide it by 4. 28 divided by 4 equals 7, so that one works. 30 divided by 4 does not work. And then our big one that we're going to experiment with, 120. Let's look at our pattern and then use that to see if we can answer this question mark. So pause the video if you want a minute to think through what you think the rule is that's happening with all of these numbers. And if you're ready, we can look at them together. Okay, so we know what numbers work and what numbers don't work. Now let's look for the pattern in them. Okay, for something to be divisible by 4 means that you can break it in half once. That's dividing by 2. And then you can break that in half again. That would be dividing by 4. So we're going to think of it that way. If you can break the number in half 2 times with nothing left over, then you know it's divisible by 4. Now our first rule is for it to be divisible by 2, it has to be an even number. So right away we know 11 doesn't work and any other odd number will not work because you can't even divide it by 2 the first time. But that doesn't automatically mean that all even numbers are good. So we know here that 22 did not work. Let's think about why. We can break 22 in half one time and we get 11. But you can't break 11 in half again because that's an odd number. Okay? Here we have 30. 30 you can break in half once to get 15, but then you can't break it in half again. So that's one of the tricks for divisibility by 4. So if we look at 120, you can break 120 in half to get 60, and then you could break 60 in half to get 30. So yes, 120 would work. So here's our rule. But there's another way to think about it if you have really big numbers. So first of all, if the number can be divided by 2 twice, then it is evenly divisible by 4. Now, if you're looking at really big numbers, you only need to check the last 2 digits. If the last 2 digits are divisible by 4, and you can tell that by using this process, see if you can cut it in half twice, then you know the entire number is divisible by 4. Okay, let's take a look at 5. Is it divisible by 5? We're going to start with a picture of 8 owls in a 10 frame. You can break that up into one group of 5, but there's not enough to make a second group, so no, 8 does not work. 15 works perfectly because you can break that into one group of 5, another group, and another group. There's nothing left over, so 15 is good. 20 is also good because you have 1, 2, 3, 4 groups of 5. It's easy to see at a glance what that is there. 25 divided by 5, we know that that equals 5. It works out perfectly, no leftovers. 42 does not work. 58 divided by 5 does not work out evenly. And 100 divided by 5 equals 20, so that one works. Now let's figure out our rule and use it to figure if 220 is evenly divisible by 5. So our rule here might be one that you already knew. If the number ends in 0 or 5, then it is evenly divisible by 5. So every one of these numbers that did work ended in either a 5 or a 0. And if you're looking at the other numbers, they do not end in 5 or 0, so you can immediately cross them off the list. So 220 does work. It ends in a 0. Okay, let's look at 6. Is it divisible by 6? So we're going to take a look first and then develop our rule for what's happening. So 8 owls, we can get one group of 6, but then there's 2 left over, so 8 does not work. 12, we can get one group of 6, and then another group, 1, 2, 3, 4, 5, 6. So 12 is divisible by 6. And then let's look at 18. We left off with our 12, so let's count again. 1, 2, 3, 4, 5, 6. So we have another group of 6, so 18 works. Now let's just go based on what we know from the multiplication tables for the rest of these. 24 divided by 6 equals 4, so that works. 30 divided by 6 equals 5, so that works. 45 divided by 6 does not. There's no easy answer for that one. There's leftovers if we do it. 68 divided by 6 does not work. Now let's look at our mystery number, 216, and find out whether that can be divisible by 6. So let's look here at everything that did work. 12 works, 18 works, 24, and 30 worked. So something in common with all of those is that they all end in an even number. So that is one thing. You can try a lot more numbers if you want to try this one. But everything that's divisible by 6 has to be an even number, first of all. And then let's take a look once again at what happens when you add the digits together on these numbers that do work. So 1 plus 2 is 3. 1 plus 8 is 9. 2 plus 4 is 6. 3 plus 0 is 3. So this should sound familiar. Once again, if the digits add up to be 3, 6, or 9, then you know that it's divisible by 3, and that's carrying over into this, divisible by 6. So we know that the numbers have to be even, and the digits have to add up to 3, 6, or 9. So we're combining two different rules here. It has to be divisible by 2 and by 3. Then we know that it's evenly divisible by 6. Okay, we will continue the rest of this in the next video. You can find it linked below.